Hey everyone, it is Mr. Vargas here, looking to help out Math 8. A little bit of a different layout today. Nevertheless, we are working on homework 3.1, pages 177 and 178, dealing with constant rate of change. Constant rate of change. Alright, some quick things that we learned in class earlier today, that if a relationship is linear, meaning it creates a straight line like that. If the relationship is linear between two quantities, then it will have a constant rate of change. So if we find that two quantities are changing at the same rate, then that relationship is linear, and you can also go the other way around. If a relationship is linear, then it will also have a constant rate of change. With that said, if a relationship is not linear, then you can probably guess that it will not have a constant rate of change. Alright, with that said, let's go ahead and look at a few of your problems from homework. We'll start out with number 15, and we are given this table of time versus the total number of people helped. So we can do this two ways. We can figure out, well, let's first talk about the question. The question says, determine whether the relationship between the two quantities shown, so this is our first quantity, our first column of numbers. This is our second quantity, our second column of numbers. Determine if those two quantities shown are linear. If so, find the constant rate of change. If not, explain your reasoning. Okay, so we need to figure out if there is a constant rate of change existing between these two quantities, h and total helped. And remember, we could do that two different ways. The first way is to determine how much it's changing from one to the other. And this time it's changing 1 on the left-hand column. And on the right-hand column, we've got a change of 12, another change of 12, but then all of a sudden we have a jump of 24. And that's not good. That is not a constant rate of change. This was constant over on our left. For every 1 we go down, we increased our time by 1. But here, every time we go down, we went 12, 12, and then all of a sudden 24. So this is not a constant rate of change. So I would write this as this relationship is nonlinear because it doesn't, whoa, sloppy writing, it doesn't have a constant rate of change. Alright, let's go ahead and jump on down to number 17. Quick side note, the other way, I forgot to mention this, the other way that we could figure out the rate of change is to just divide the right column into the left column. So here I would do 12 divided by 1, and that would give me a rate of change of 12. Here I would do 24 divided by 2, and that would get me 12 as well. 36 divided by 3 would get me 12. And here, 60 divided by 4 would get me 15. So once again, we can see that that is not a constant rate of change. Let's go ahead and look at number 17. We were given this graph with these points. Now, we're going to learn a little bit about this later, but we could connect a straight line through these points, making it a linear relationship, and thus you know it has to have a constant rate of change. So let's figure out what that rate of change is. And the way that we do that is we determine how much a point changes going up and down over how much it changes going left and right. And what this is called is your rise over your run. So how much does it change going up or down, rise or run, divided by how much does it change going left and right. And that is your rate of change. So if I look at this example, let me zoom in really quick, and I go from this point down to this point. First I have to check and see how far does it go straight up and down. Well, it would go straight up and down here, arrive at this point, and then it moves to the right all the way over here and finally becomes that new point. So let's check out the change. Let's check out the rate of change. Well, from this point straight down to here, it went down 100, right? 350 minus 250 is 100, so we lost 100 points, if you will, points. And then from this blue dot here all the way to where it is now, standing on the line, it went, let me see, over one space, two spaces, because it's at 2 down here on our x-axis. So here it moved over 2. So if we wanted to write that as rise over run, we would say it went down 100 over 2. So that's the rate of change, negative 100 over 2. We could simplify that. Negative 100 divided by 2 is just negative 50. So this has a rate of change of 50 per 1 hour. So you would go 50 miles, you would decrease 50 miles every 1 hour. And if you want to check to see between these 2 points, we could do the same type of thing. Let me get a different color here. But if we were to go from here down to here, first we would want to determine the rate of change up and down. It goes down here, and then it goes right, 1, 2. We know that when it goes from this point down to this point, it's actually losing 100 based on our graph. It goes from 250 to 150. So once again, it would lose 100, and then it would go plus 2 spaces to the right, giving us a rate of change of negative 100 over 2, which is just negative 50 over 1. So if you want to write about the rate of change for this problem, I would say something about the rate of change for this graph is negative 50 over 1, and that's miles per hour, which basically means you decrease 50 miles every hour. Okay, let's check out that next one, number 18. This will be the last one that I talk about. It's been a long video already. Alright, so here we've got a graph, And the y-axis has to do with our earnings in money, and then the x-axis has to do the amount of time that we worked in hours. Okay, so this one should be a little bit more straightforward maybe, but check it out. If I work 0 hours, guess what? I make 0 money, and that's this point right here. And then if I work 2 hours, I make $10. And then if I work 4 hours, I make $20. So in order to determine the rate of change for this graph, once again, we're going to talk about the rise over the run, which basically means how much did it go up or down, over or divided by how much did it go left or right. There we go, that's better. Okay, so let's go from point to point and see how much it goes up or down, and then how much it goes left and right. We'll zoom in at this point. This is 0, 0. And first, let's go ahead and jump up. It's going to jump to this spot right here. Okay, and that means it increased 10. So that would be our rise. Let me fill that in right here. That would be our rise, 10. And this is dollars over. Okay, let's see how much it ran, or it runs. It would run from left to right, 1 space, 2 spaces according to this x-axis. So that would be an increase of 2 hours. So rise over run would be 10 over 2, or $10 for every 2 hours. You could simplify that, and you would find that you are basically making $5 for every 1 hour of work. Alright, if I had to write that as a mathematical sentence, I would say the rate of change for this graph is $5 for every 1 hour, which means I earn $5 per hour. Alright, that does it for me. Really quickly, I want you to double check and see if that also holds true from this point to this point. Do you get the same rate of change when you go rise over run from this red point to this red point? Alright, see you in class. Good luck on the rest of the assignment.